In this tutorial I will demonstrate how you can create a basic hiking app using this .NET MAUI cross-platform app development framework from Microsoft. You use this .NET MAUI framework in Visual Studio, and you use the C# programming language. In this hiking app we are going to use different sensors that are built into most smartphones today, like this barometer, compass sensor, and we will also create some navigation through between different pages using a built-in feature called AppShell. So here you see the contents of this tutorial. First a short introduction, then we will create the foundation for the hiking app, then we will create the different pages for the barometer sensor, the compass sensor. We will also create a weather page where you can see different weather conditions. So here you see the draft of the graphical user interface. So you have a home page where you just present some information about the app itself. Here you can of course add more information. Basic to just add a button here, and when you click on this button you will open a web page with more information about hiking, etc. And then you have different pages for the different sensors, for the barometer sensors, for the compass sensor, and weather information. So we will start with a short introduction to the hiking app and this .NET MAUI framework. So this hiking app that we are going to create, it's a basic hiking app that uses the barometer sensor, the compass sensor, and also retrieves some weather data. In this basic application we are going to create here, I'm just for the weather part, I'm just going to create a link or a button that you can click on and open a weather service like yr.no, but even better, you should be able to retrieve data from one of these weather services using a web API, etc. But that's not part of this tutorial. The barometer can be used to check if the weather will be good or bad when you are going to go for hiking, and you can also use it to see if you are going to some mountains for hiking, etc. We can see how high you are above the sea level. And the compass sensor can be used for navigation and find correct direction during your hiking trip. And of course the weather and forecast information can be used to check the current and future weather condition when you are going for hiking. So here you see an overview of the different pages that is part of this hiking app. Here is the home page, and then when you click on barometer you will open this page where you can get information about the barometric pressure and height above sea level. And you have buttons for start and stopping reading information from the sensor. And if you click on the compass you will get to this web page where you can use it as a compass to see which direction you are going into, north, south, west, east, etc. Also here you have buttons to start, stop reading from the sensor. And this, when you click on this weather page you will open this one. It's just a basic web page where you have a button, and then when you click here you will open an external weather service like yr.no to see the current weather condition and weather forecast. And here you can of course improve it by retrieving directly weather data from one of these weather services using a web API, etc. So this .NET MAUI framework is integrated with Visual Studio and is created by Microsoft. You use this .NET MAUI framework to create apps for your smartphones, either it's Android, an iPhone, etc. In order to start working with .NET MAUI, make sure that you have installed this .NET MAUI workload. So basically go to the search menu in Windows, search for Visual Studio installer, and see if this workload is installed or not. When you have installed this workload and then you create a new project in Visual Studio, you should be able to see this .NET MAUI app project. If you don't find it, just search for it here, and if you don't find it, make sure you have installed this .NET MAUI workload. So let's start creating this hiking app. We create it step by step. So I start by creating this navigation bar here in the bottom, where you have home, barometer, compass, weather, and you can also add more tabs here. In order to create that one, typically you need to have some icons. You can download icons from internet, etc. And then you need to create one page for each of those tabs in the Visual Studio project. So in order to create the navigation you find here in the bottom, you need to use a feature called .NET MAUI shell. You use it to create multi-page applications with tabs or flyout navigation. We will focus on tabs in this tutorial, tabs like this. So this navigation bar is created in a file which is part of the default template called AppShell.xaml. So here you define the different tabs with icons, text, etc. And then later you need to create additional user interface files, XAML files for each of the tab items you find here, or that you define here in the tab bar. So here you see an example of this AppShell.xaml, where I have defined a tab bar with a so-called shell content, and then I have one for the home, one for the barometer, compass, and one for the weather. And then here I define a title, and here on the content template you define the name of the XAML page that should be shown when you click on the home tab, and the same for the barometer, compass, etc. Also you define an icon that you want to be present on the different items in this tab bar like this. And of course you can find these items or similar icons on internet, or you can create them by yourself from scratch. Another option is to use the icons library in PowerPoint. Basically just go to insert and then icons, and then you will get a list of thousands of different icons that can be useful in any kind of situation. So basically if I want to see if they have a compass icon, I just search for compass, and then you will find different icons that you can use, and then basically you can just right click on those icons and save as image in order to use them in your application. So let's go to Visual Studio to start creating this hiking app and create this tab bar or navigation bar by including the different tabs in this AppShell.xaml, and also include a set of icons that you either can find on internet or create by yourself, or use the icons that you find in PowerPoint or other applications. So now I have opened my Visual Studio. I just click here to create a new project. I find this .NET MAUI app template, click next. I select a proper name for my application, in my case hiking, and also specify a location like this. Click next, and then just make sure not to select those, and select the latest framework and click create in order to create this project on your hard drive. Well, I have already a project with that name, so I'll just click no, go back here, hiking, just select a different folder. So I just have a temporary folder here, click .NET MAUI and select it here. Then the name of the project is hiking, and I put it in this location. Click next and click create. And then typically it takes some seconds to create the project with necessary folders and files in Visual Studio. Yeah, so here you see the default project has been created with necessary folders and files, and here you see this AppShell.xaml which we are going to use to create the navigation. And then we have the different pages here. We can use this default main page.xaml as the home page, and then we need to create more pages for the barometer, compass, and weather pages. And the icons that we are going to use, or the images, could be put under resources, and then there's a pre-made folder called images where we should store our images. Then I have just a folder here called images with the images or icons that I need to use in this application. So basically I just select them and put them in the images folder like this. So now we have the necessary icons that we are going to use in this application. And now we can create the contents of this AppShell.xaml to create the tab bar or the navigation bar. So then I just use this tab bar that is part of .NET MAUI like this. So that's the start, and the stop needs to be put down here like this. And then we need to create the different items in this tab bar like this. So then we use this shell content. This is the home page, and then we just use this main page, which you find here. Of course, we need to change the contents and make it the way we want to have it. Instead of routing, I can just use an icon. And then we have the different icons here in the image folder, and here for home I just want to use this hiking or home. Do I have a home here? I have a home icon, so then I just use home.png like this for the icon. So now we have a title with home. We define which page should be shown when we click on this home item and the icon that should be shown. Then you can do the same for the others. So we have this barometer page. That we need to create later. And we have the compass page, and then we have the weather page. Then I just need to do some formatting here. This, and now we have the home here. I changed it to barometer, and then we haven't created the barometer page yet, but let's assume we call it barometer page like this. And then we have the icon here, barometer. The same for the compass. And later we need to create a compass page, and then finally the weather. And here for the compass we also have a compass icon, which you have here, and weather. And then we will create later a weather page, and we have an icon called weather.png like this. Now we have created the basic structure or contents of our application. So the next step now is to create, we have already created the main page. It's part of the default template. We just need to change the contents later, and we need to create a barometer page, a compass page, and a weather page. And then basically we just go here on the project, right click, add new item, and then we select .NET MAUI, and then we select the .NET MAUI content page, which is a XAML page, and then we just define the name of the page, which should be barometer page like this. And then you see it has been created here with a barometer page.xaml and a page behind file called barometer page.xaml.cs, where we are going to create the C# code. Then you do the same for the others. new item, .NET MAU, and .NET MAU content page. We call it compass page, like this. And this, finally, the same for the weather page. Like this. So now these different pages has been created here in part of the solution in our project. Let's just close all here. Just have this this AppShell.xaml page open, and let's open this home page, which we find here, which is this main page, which is located here. So this is the default home page. So far we just leave it as it is, and then we will change it later. And then the Barometer page, which is created here. You see this is just the default page, the same for the compass page and the weather page, etc. We'll change the contents later, but let's just start application. We will select Android emulator and just use the default one, and just start our project to see how our application looks like at this point. So now our application has been opened in this Android emulator, which is part of this .NET MAU framework. When you install it, the Android emulator will also be installed, and it looks like this. So now this is basically just the default application, where you can click on this button and you have an image, etc. Of course, we need to change the icon, the text here, change it to hiking app, welcome to the hiking app, etc. Here we could click on the button to open a web page with more information, etc. And then you see here in the bottom we have the different items for the navigation bar or the tab bar. We have the home, which is the default one. Then you can click on the Barometer, and so far it's empty, so we need to create the user interface and the code to interact with the barometer sensor and read information from the sensor. And then the same for the compass here, just an empty page. We need to create the contents and the C# code to create interaction with this compass sensor and to read information from it. And then finally we have the weather page, also empty so far, so we also need to create the contents for this web page as well. But that's the starting point, so let's start creating the contents for the different pages step by step. So then let's start with the main page or the home page, this main page.xaml. So here is just the default layout and contents created by this default template, so you can use it as a starting point. We can have an image here, and you can use one of the images I have included here, like this hiking.png image, like this. So I just use this one instead. Hiking. I can put the title above the image like this instead, so you can change the layout any way you want to have it. So here I have a title instead of Hello World. I change it to hiking app or something, and then you have the hiking image. Then you can have a sub-label, welcome to the hiking app or something. This one is not so important, so you can just remove those. And have a ending tag here, like this. It also have an ending tag here as well. So that's label, the header or title. We have an image and a subtitle. We also use a label, welcome to the hiking app, and then you could have this button in order to open a web page or something. So we need to change the name. We can just call it button web site or something, and the text open web site. Then this hint, you can just remove it so far, and then click. Here we define the event handler, so when you click the button, then we define what should happen in the code behind file in this main page.xaml.cs. We need to create the C# code for this event handler. We can change it to on button clicked or something like this, and so now that's the default contents of this home page or main page.xaml. Then you can go to the code behind file or the C# code. You can just start by deleting some of the default code. So here is the old button handler. You can just delete it like this. And then we need to create the event handler for our new button, which you have here in the main page.xaml. And here, then basically just click here, right click, and then go to definition. And then the event handler will be created for us. So now we can just start creating the code. Many ways to do this. We can just start by showing display some information to the user, or we can open a web page. So let's see how we can open a web page. Then basically you can use something called the launcher default open async and the name of the web page like this. You can specify any kind of web page. Since this is an open async, we should also have this await in front here, and here we should also specify that this is an async method like this. So basically that's it. So when you now click on the button on the home page here, it goes to this piece of code and open the default web browser, which is part of your smartphone, and then just open the web page that you specify here. So the next step would be to create the contents of the different web pages. So let's start with the barometer page. Just a short introduction to this barometric sensor. The barometric sensor measures the ambient air pressure, so it can be used in many different types of applications, and it's super handy to use in this hiking application, where you can use it to see if we get into a bad weather or if there will be good weather today based on this ambient air pressure level. And the data presented from the sensor will be in hectopascal, or shortened hectopascal. And we can use this barometric formula to estimate or calculate the height above the sea level according to this barometric formula, which we can implement in our C# code. So that's this formula. So let's start creating the user interface for the barometric page. We're going to read barometric data using the barometer sensor, which is part of the smartphone. We can create a basic title. We can include an image, and then here you see the actual value, the ambient air pressure value that comes from the sensor in hectopascal. And then we can use this barometric formula to calculate the height above sea level and present it here. And then we can have some start-stop button to start reading from the sensor and stop reading from the sensor. So then we are back in Visual Studio, and then we open this barometer page.xaml page. So then we have the XAML page where we define the user interface, and then we have the code behind file where we define our C# code. So let's just open the user interface page to save some time. I just copy a pre-made code like this. So here we define the different elements in the user interface. Here we have a label, which could just say a barometric sensor. So this would be the title of the page. And here we can include an image. And then I just use the image that you found here under images that we just included previously, this barometer.png, which is this one, and some other information as well. And then we can include a sub-label for where we are going to show the actual air pressure value, and another label where we are going to present the height above sea level. And then we have these two buttons, one start button with a name, text, what should be presented or shown on the button, and then we have an event handler here on start click, and the same for the stop button, should say stop, and then we have an on stop clicked. So these event handler, you can call them whatever you like, but we need to define these event handlers in our code. Basically we can just click on them, right click here, and then go to definition, and then these event handler will be created for us. And the same for this stop button, on stop clicked, right click, go to definition like this. And now we have the basic structure in the code behind file. We have a start button with an event handler, and we have a stop button with an event handler. So now basically you just need to create the necessary code to start reading from the barometric sensor, and here we need to stop reading from the barometric sensor. And then also we need to create a new event handler that reads data from the sensor when changes occur in the sensor readings. So in order to save some time, I just copy in some pre-made code, and then use the built-in barometer class and methods that are available. So the first thing we need to do here in this line of code, we need to create an event handler, which we will create later here in the code. So then this line of code starts the reading from the sensor, and here when we get some values from the sensor, this barometer underscore reading changed will be executed. So then inside this event handler we need to create the necessary code to read data from the sensor. And then we have these two start and stop buttons. When we click on the start button, we can disable the button and vice versa. So that's the code for the on start clicked, and then there will be similar code for the on stop clicked method. So I can just copy that code and just change it to. So the first thing we need to do is to stop the sensor. So then instead of start, we just use the stop method like this, and here we need to just remove this event handler, and then we just, instead of plus, we just use minus like this. And then when we stop, we should enable the start button and disable the stop button like this. We can also add some text. As you see here in the SAML file, we have the label height and the label pressure. So here we should present the values. You can just, when you stop the reading, we can just do like this, label pressure like this, and dot text, and then you can just set it to not any value or something like this. I'll do the same for other. Label, the other one was label height. Like this. So when we stop the button, we just present no data available because we have stopped reading from the sensor like this. So now we have on start clicked and we have on stop click, and now we need to define this method in order to create the code for reading data from the sensor. So in order to save some time, I just copy in some pre-made code for this event handler like this. So here we basically use so when the sensor is started and we retrieve values from the sensor, this piece of code will be executed, and then we just create a variable and use this e.reading and pressure in hectopascal, and then the value from the sensor will be put into this variable, and then you can present it here on the user interface in this label pressure. You can convert it, make sure it has one decimal, and include the unit as well, like this. And next we also want to calculate the height above the sea level, so we just create a method for that, call it calculate height or whatever you like, and then we call it here. So this method basically are using this barometric formula to calculate the height above sea level based on the readings from the barometric sensor like this. So now basically we have what we need. We define the user interface here with a title, an image, and two labels where we are going to present the values from the sensor and the height on the start and stop button, and then we create the necessary C# code, one method that starts reading from the sensor, one that stops the reading from the sensor, and then one method that are actually reading the values from the sensor, and a method that is calculating the height above sea level. So basically now just save it and let's start running the application and see what the application looks like at this state of the development. So now we get the results here in the Android emulator. The start page is the same. So now we have just a welcome message here. We can click here to open the web page, etc. But let's go to Barometer, and then you see we have this title and image, and then we have labels for showing the barometric pressure and the height above sea level, and then we can start and stop the reading. So let's just click start, and then you see we are actually able to get some values from the sensor. But let's test it. Let's go to these three dots to get access to these extended controls, which is part of this Android emulators. And here you have a feature called virtual sensors, and then you see here you have this pressure sensor. Then basically you can just simulate the results from the sensor using this Android emulator instead of a real Android device. Then you see the value here is the same as you see here in the application, and then here you see the calculated height above sea level as well. So then you can click on stop, and then you see it goes to not any data. Then you can click start again, and then you will get the necessary data. So basically now we have this home page ready. Of course we can include more text and more information here, and then we have the barometric page ready. So let's do the same for the compass page, which is more or less identical as the barometer page, where we're using the compass sensor instead of the barometer sensor. So next we need to create the contents of the compass page. Basically the compass sensor monitors the device's magnetic north heading, so you can use it to find or navigate and find directions when you are going for a hike. So here is the contents we are going to create. It's very similar to the barometer, but instead of reading from the barometer sensor, we are going to read from the compass sensor. And here we have a reading from the sensor. It's a value between 0 and 360 degrees. In addition, I also want to show what direction, like north, south, west, east, etc. And then we have the same buttons for start and stop reading values from the sensor, and also an image, title, etc. So in order to save some time, since this compass page is very similar as the barometer page, I just made the code already. So then we have the compass page.xaml, where we have this label, where we have a title, an image of a compass, two labels where we're going to present data from the sensor. Here, value in degrees between 0 and 360 degrees, and then the direction, north, south, west, east, etc. And then we have these two buttons, start button and stop button. So that's the user interface, and then we go to the code behind file. It's more or less identical as the barometer page, where you have on start clicked. So instead of barometer, we use the compass object, which is part of .NET, but the code is similar. Here we have the on stop, which is also similar, but we use the compass object instead. And then we have this on compass reading change, which is the event handler that is executed when we get values from the sensor. And then we just create a variable, compass degrees, and then we read the values from the sensor. And that's a value between 0 and 360 degrees, which we just put on our user interface in the label compass degrees, which we have here in the user interface. And then also similar as the compass, as the barometric sensor, we create a separate method to also display the direction, north, south, east, west, etc. So we have made some basic logic here to define based on the degrees between 0 and 360 degrees, either if you are pointing to north, south, east or west, like this. Let's just open or start the application and see how this is working. So now the application should look something like this. So we have the home page with some basic information, and we tested already this barometric page, and now we have this compass page. When we click here, we should be able to read the direction and which direction, north, south, west, east, etc. And then you can click start, stop to read and stop reading from the sensor. And now the same here, if you want to test it, we go to these three dots, open these extended controls in the Android emulator, go to virtual sensors, and then we have something here, device pose, and then here we can simulate the movement of our application, of our physical device using this emulator. So then you can, let's say, you can change it here. So now, you see now, when I do it like this, you change the direction, and now if I turn the phone like this, it's north. When I turn it like this, it's east, and when I turn it the other way, it's west, etc. So then basically we can use these extended controls and this virtual sensor to simulate the behavior of our physical Android device like this. So next now is to include the weather part, and also see here in the bottom I have also included another page called steps. So let's go through these details as well. So let's start with the weather. Basically the weather page, just like the other pages, a title, an icon, and just a button. When I click on this button, I basically just open the yr.no webpage to see actual data. No, it was crashing. Yeah, it was crashing. So let's go back to the web page, open this yr.no web page, and then you see you will retrieve weather information from different locations. And if you don't find your location, you can just search for your specific location to get weather condition and weather forecast for your specific city, like this. And then I just select this one, and then you see the current weather. You see weather forecast for this night, the next day, etc. And also, in addition to showing data from the barometer sensor and the compass sensor, typically you also want to use the accelerometer, which is part of most of the smartphones today. So you can use this accelerometer sensor to measure steps that you are taking during your hike. So basically, this steps functionality could be handy to include in your hiking application. So typically you want to count number of steps that you take. You also want to calculate the distance that you take during your hiking, and for that purpose you can use the built-in accelerometer sensor that is part of most of the smartphones that we have today. So then this accelerometer can be used to count the steps, and we can also use a basic formula to actually calculate the distance in either meters or kilometers by using just this basic formula: distance equals to steps multiplied with step length. And then here this step length could be different, either you are a man or a woman, because typically men have longer legs, so you need to use a different value for men compared to women, like this. And using the accelerometer sensor is very similar as the other sensors that we have used, the barometer sensor and the compass sensor, and also the user interface may look very similar. We have typically include a title, an icon or an image, number of steps, and then the calculated distance in either meter or kilometer. And then we can have start button and a stop button as we had on other pages as well. And here you see the user interface created in this steps page.xaml. So we need to create this new page. We can call it steps.page, steps page.xaml, or whatever you like. And you also need to include that page in the navigation bar, as you see here. And similar as for the other sensors, we need to have a on start clicked event handler to start reading from the sensor, and a on stop clicked in order to stop reading from the sensor, and then the actual reading. Here we can create some code like this. Since this accelerometer is reading values in 3 directions, X, Y, and Z, we can use that information according to this formula to actually see if the phone that you hold in your hand or have in your pocket actually is moving or is in the same position. And then we can include some kind of a threshold to register a new step if the movement is large enough. So we can basically use the accelerometer sensor with some basic formulas and logic to actually register number of steps. In addition, we can also calculate the distance in meter. So then I just, as for the previous sensor, I just create a separate method, in this case call it distance, which is actually using this formula that we are talking about. Distance equals to number of steps and multiply with the step length, like this. And also in this here, I present the value in this label distance, which is part of the user interface. And also if it's above 1000 meter, I don't use meters as the unit, but I use kilometer instead as a unit, like this. So now we are back in Visual Studio, so let's just open these pages. So let's start with this AppShell.xaml. Here I have included a shell content for the steps page as well. So now we have a home page and a barometer page, compass page, a step page, and this final weather page. So that's the AppShell.xaml that we need to update with this new information. And then we needed to create this new page, steps page.xaml. And the user interface is more or less identical as the other pages. with the labels, image, and 2 buttons. And then we have the code behind file, where we have the on start clicked, on stop clicked, and the actual event handler for reading data from the sensor. And finally, this method for calculating the distance in either meter or kilometer like this. Let's just start the application and see the final results. So this is the final hiking app, where you have this home page, the barometer reading, you have the compass reading, and then we have this weather, where you can click here to get information from this weather service. And then finally we have this steps page, which is a new page that we created. And then we can have these buttons to start and stop. And then you can also use these extended controls. You can click here on virtual sensor, device pose, click to move, and then we can start doing some movement on our phone to simulate actual movement with either where we have our phone in a pocket or in our hand when we are walking our hike, like this. And then you see we get increased number of steps, and then we also measure the distance in meter like this. So we just move around with our phone to simulate movement, and then number of steps will be increased like this. Basically, this is a basic hiking app with standard functionality as using the barometer sensor, the compass, and the accelerometer, and also showing some weather condition. We have used this navigation or tab bar in order to be able to use different pages, one for home, one for barometer, one for compass, one for steps, and one for the weather like this. So basically that's basic hiking app created with .NET MAUI using Visual Studio and the C# programming language, and we have tested it using this built-in Android emulator and these extended controls to actually simulate the behavior of the real physical Android device in this case. So that's all for now, so thank you and goodbye.